This is part 1 of chapter 15, non-renewable energy and electricity. So when we talk about energy, we talk about primary energy and secondary energy. Energy contained in natural resources is what we call the primary energy. So that means it's the actual item. So coal, oil, sunlight, wind, uranium, right? But then what it becomes is the secondary thing. So remember, primary is what it is and then what it becomes. So secondary energy is when that primary energy is converted into another form, which then it becomes electricity in a lot of cases, or fuel, etc. So one thing that it's just like primary and secondary pollution, whereas the primary comes right out of the stack, secondary is created through a chemical process. Well, same thing here, right? So primary is the actual item, then the secondary is what is produced from that item. So when we talk about the forms of primary energy, they can be divided into two subsections, either renewable or non-renewable. Non-renewable are derived from sources that exist in limited quality. You're talking about your fossil fuels, your uranium, all of your different types of non-renewable resources. That is coal, oil, etc. Your renewable are sources that are not depleted when used or can be replenished quickly, and this is solar, wind, wood, etc. And this just kind of gives you an idea of fossil fuels account for 80% of the primary energy resources consumed by humans, which is, of course, a big problem. It's a huge problem. So the end use is the rates of primary energy consumption vary by country, and of course the consumption can be broken into 4 sectors. So we either use primary energy for transportation, industry, residential, commercial, residential/commercial, or electricity. The world's 50th richest countries have only 20% of the global population, but account for more than 70% of all primary energy consumption. The United States actually has less than 5% of the global population, but accounts for nearly 20% of energy consumption. Isn't that crazy? I mean, it's just unbelievable. So future energy portfolios, the future patterns depend on 4 factors, and that is the size of the reservoir, how fast we extract, what is going to be the market price for that, the energy return on investment, and what are the environmental impacts. And so this is a big deal. There are growing concern over the long-run availability of some of the fossil fuels that dominate our energy economy. The proven reserves of non-renewable energy sources are quantities of fuel that could be recovered from known deposit using current technologies. The reserves to produce, or the RP, which is the reserves to production ratio, is proven reserves figure for a given fuel divided by the particular year's level of production or use. These reserves to production ratio provide an estimate of how many years a fuel will last if the level of production remains constant and no additional reserves are discovered. And so this is really important for you to know. For example, the reserves of oil that can easily be extracted from the ground have a high energy return on investment. As more and more oil is pumped from the ground, though, that energy return on investment declines, since the remaining reserves of oil are likely to be in remote places and really hard to extract. So we're talking about maybe under Antarctica or other areas. So now we're going to go through each one of the non-renewable resources. The first one is coal. Coal is formed from plants hundreds of millions of years ago. It is put under extreme pressure from either the rocks, etc., pushing down on it, and what happens is it becomes this viscous material. Today, coal meets 28% of the global energy needs, and it's the most abundant of all fossil fuels and appears to be sufficient to meet global demands for the next century. So as that pressure pushes down, it turns into a specific rock. I don't mean, I was talking about oil a minute ago, but the pressure, it becomes a metamorphic rock, which is transformed into coal, and this is what happens. So here are the different types of coal. And these have different energy content per one. And one of the bigger issues is that some of these actually are some types of coals have a higher sulfur content in them than others. So how is coal extracted? Well, it's removed from sediment by underground and surface mining. So we remove it from the ground through mining. We can either cut off the top of the mountain and extract it that way, or build mines under the ground. It is clean to remove the dirt and impurities. This is a big problem because we actually wash the coal, and then that hazardous water has to be cleaned. A lot of times we just put it in holding tanks and then clean it later. But sometimes that, and this happened maybe about 2 or 3 years ago in West Virginia, that actual water wound up polluted water wound up in the river systems, and people couldn't drink water for like almost an entire summer. It's a big problem. Globally, 60% of used for electric generation, 90% in the United States, although we're kind of really moving away from that. We have dual plants now where we use coal and natural gas. And since natural gas extraction rates have become so high and cheaper, we've been using natural gas more than coal. And so it's transformed into electricity. Coal-fired power plants, what they do is they use the coal, they boil the water, the steam from the water turns a turbine, which creates electricity, and then that's it. So it's a pretty simple process. Here's an example of a coal mine, and here is what looks like surface mining. So this would be an open pit mine where we lop off the top. You can see here, like at one point a mountain existed, and now we've dug all the way down. This is just showing you how it happens. The coal is burned. This is the coal hopper. The coal is burned. It boils water. The steam turns a turbine, and then of course that hot water has to go into a condensing tank to cool down, and then use it. Now scrubbers, we use scrubbers to remove the pollutants such as SOx and NOx from the exhaust, and then usually the SOx and NOx, in here the scrubbers go in here, and they remove the pollutants from it. What are the environmental impacts of coal? Well, big deal. Mining destroys habitats, mountaintop removal. The mine tailings are acidic, and these are mine tailings. This is what is used to wash that coal with, and then sometimes it ends up in our water streams. The exhaust from coal burning power plants, of course, is a huge concern in terms of greenhouse gases and the greenhouse effect in climate change. This is an open pit mine. You can just see there's a lot of issues with it. Let's move to oil. So oil forms under specific geological conditions. It has to be under a lot of pressure, and it's formed from the remains of microorganisms millions of years ago. They become trapped beneath the permeable rock, and they become oil reservoirs. So it's a really thick, viscous material. Oil is like a sludge almost when it comes out of the ground, and then it's refined into different types of oils that we can use. And that sludge is, it's a big deal. But this is a big. We use oil a lot, and a lot of it, of course, is found under the ocean floors, and we have to drill really far for it, which could become a problem, like the Gulf oil spill. So here you go. This is where you can see it's here. It can form oil reserves, or here we have to drill all the way down to get them. The environmental impacts, of course, the drilling and transportation of oil is a big deal. The oils, the Exxon Valdez spills, the Gulf oil spill, lots of problems. When we burn oil, we, of course, release CO2 emissions, carbon monoxide, hydrocarbons, nitrous oxides, and, of course, it's another type of greenhouse gas emission. We also have a lot of oil reserves in pristine places. This is what we call ANWR, the Arctic National Wildlife Refuge, and this was under a huge concern a couple years ago. The Obama administration said that we wouldn't drill in ANWR for oil, but the Trump administration has talked about that now. It is a very fragile ecosystem. It's one of the last untouched human ecosystems, and there are a lot of people who want to drill for oil there and then build an oil pipeline all the way through the United States. Parts of that actually have already been built, and it's a big controversial issue. Here's an oil spill. This is a big problem in terms of that. Natural gas extraction. So natural gas is a third type of non-renewable resource we're going to talk about. The sources and amounts vary. The United States, of course, happens to be sitting on large, what we call Marcellus shale fields, and Marcellus shale just happens to be a viable place for natural gas to have been created. It's usually found in association with crude oil deposits. It's also found in what we call coal seams. And 65 years supply exists at the current consumption rate. That has significantly dropped because we are using more natural gas. Fracking is what we use to extract natural gas. So what we do is we drill a well down, we inject water with chemicals in it that break apart the rock, and when we break apart the rock, the natural gas is released. We suck that up through a well. And there are a lot of massive problems with natural gas extraction. If you've ever seen the movie Gasland, or if you haven't, make sure you get your hands on it. Gasland 1, Gasland 2 shows you all of the major problems with natural gas extraction. There are lots of current environmental day issues going on with natural gas extraction and pipelines running through, especially the city of Philadelphia. What they want to do is they want to, from the natural gas extraction points in Pennsylvania, they want to run a pipeline all the way through Pennsylvania and then liquefy that and put it on ships and send it overseas. One of the bigger problems is like now you have this pipeline of natural gas, which is highly flammable, running through people's towns and cities. Big problems, huge problems with it. So the extraction and process, it's sent to refineries by pipeline. It can be converted into liquid natural gas, LNG. It's largely used in industrial and power generation, and some used for production of plastics, fertilizer, synthetic products, etc. This is what it looks like when it's liquefied. As you can see, no smoking. Please, no smoking with natural gas on board, because that could be a big problem. So what are the environmental impacts? It, of course, burns cleaner. This is why everybody puts their money on natural gas. It burns a lot cleaner than any of the other fossil fuels that we have available. But, of course, it has issues with the extraction. Fracking is a major issue, and you're going to read about it under this session. And of course, still, even though it burns, it still does have CO2 that it releases into the atmosphere, but it is, of course, smaller. I'm going to stop here and start part 2 because we're going to talk about nuclear power.